Welcome back, chat. Looking at it as we're going through, appreciate the subs, Aura coming your way. I see some comments in the chat though. The first one, let's check it out. We're all gonna read one. First one that comes up, Fred has a great sense of humor. Interesting, cool. Thanks for the sub. Another one?
Freddie got a nice haircut.
Fred's got a nice haircut, I like it.
Freddie has nice style.
He's got style, drippy is what I heard.
Oh, I was outside your house.
Should have saw that coming.
I like his nails.
Good.
He has very white teeth.
He has nice teeth. Cool. Do me one favor. Compliment each other real quick. I'm going to take attendance. So, yesterday we were finishing up 5.2, I think.
Yeah.
Pretty sure it's 5.2. And looking at it, we looked at some human impact, and then we took a kind of random trip down the scary disease of prions randomly, but that's fine. Then we came back to pollution, which is an unfortunate thing that happens, constantly. We're looking specifically at mercury. Am I concerned about the amount of mercury that's just in open water?
Yes.
No. Look at how tiny that is. That's that many parts in a million particles of water. So that's almost nothing. Okay. Plankton eat it, and it gets more concentrated. Bigger fish eat the plankton, gets more concentrated. Even bigger fish eat those fish that ate the previous level, and now we get a bunch more. As we're going, we didn't define this. Do you see anything that one could argue is magnification happening?
Something's getting bigger and bigger.
This concentration is getting bigger and bigger as we go through the food web, right? Or through the food chain. As we look at that, then, we have a nice way to define this. We're going to say that our biological magnification is simply going to be an increase in concentration, which we're not talking about like thinking really hard about something. We're talking about how much of concentrated it is. The increase in concentration, goodness gracious, as we move, and I'm going to give you guys, I'm going to say a different one than we write is my guess. I want to say as we move through trophic levels. Remember, way back earlier, we had all those levels of an ecosystem where you have the autotrophs and then the primary producers and primary consumers. Those are all trophic levels. We can word it like that if you want. Or alternatively, we can say as we move up, I'm going to put quotations around that, the food chain. Okay. It happens with a lot of different environmental chemical pollutants that we deal with. Mercury is a big one that impacts, who were we talking about yesterday with mercury?
Cows.
Wasn't cows. We did talk about Alice in Wonderland because Matt is a hatter, right? We talked about how it messes with your brain when you get poisoned with it. Who shouldn't eat tuna and when? Pregnant women, because why? It could hurt the fetus, right? Now, I eat tuna. Fetus is just what you call it before it's born. I don't know, it's a language thing. It starts with an embryo, and then it's a fetus. And then once it's born, it's a baby. We're not going into that detail, though. Okay, anyway, as we go through here, have you guys ever eaten tuna?
Yes. Yeah.
Are you currently undergoing mercury poisoning?
Yes.
No, you're not. Not unless you're playing with crazy amounts of mercury outside of that. Even if you eat like a ton of tuna all the time, as big people like us, we're okay. You know who's not big people like us? Fetuses, right? They get all their blood from the mother. They do not have the ability to fight it off because they have significantly less blood. Cool. As we go through here then, this is an issue. Other places, notice, big fish get lots of it. Birds take a whole lot of it. Do you guys know of any other pollutants that exist? Like any scary, obviously you know of a lot of pollutants. That would make sense. Have you guys ever heard of DDT?
The gas? No.
It's not gas. What do you mean, depending on what you're...
Like, that put in the gas, that affects the animals?
Oh, you're talking lead. Okay, back in the day, huge issues. Right now, if you buy gasoline at the pump, you guys pumped gas before?
Yeah.
What sort of gasoline do you buy?
Unleaded.
Unleaded. Unleaded. Good call, though. Do you know what lead is? Lead is an element. It's Pb. It is not, just so you know, pencil lead is not lead.
Like lead poison?
Yeah. So, for a long time, gasoline had lead in it, just because it's part of the production process. And when you burn gasoline, specifically, you know, to power a vehicle, it releases exhaust, right? And that exhaust has a bunch of different stuff in it. It has CO2 and it has some other byproducts of that combustion reaction. There was also a bunch of lead in it. That is a huge issue. Lead poisoning, much like mercury poisoning, impacts the brain. Lead is a heavy metal. These things cause havoc in your nervous system. Turns out with children with lead poisoning, it's more of a concern. It can lead to lack of development in the parts of the brain that help you to control your emotions, which means if I drop something, like I might swear depending on what it is, but like I'm not gonna throw a fit and go into a blind rage punching walls and stuff if I just drop something, right? I don't think you guys do either. But if somebody doesn't have the ability to control their emotions, their aggression levels could be through the roof. That's one of the impacts of lead poisoning. Now, luckily, we've taken lead out of gasoline. That's why it's called unleaded gasoline.
So like anger issues.
Could be, yeah, definitely. I don't know for sure, but when I think, are there groups of people that, age groups specifically, a generation that seems to get angry about stuff than others? Who? Teenagers uniquely do, but that's always going to happen whether it's lead or not, because, yeah.
It's like 7, 6-year-old, like.
So also same thing, children struggle because it's developing. Who do you think gets more upset about dropping a cup? Me, which I'm, how old?
Oh, an older person.
Older people, I'm 35 if you guys remember. Remember, that's a secret between us. Older people oftentimes, my mom, I don't know about your grandparents and stuff, but my mom blows up at the smallest stuff. My mom was around 50 years ago when there was lead in the gasoline and therefore lead fumes around. Maybe there's a connection, maybe there's not. I think it's just an interesting observation. However, lead poisoning was a huge one. Beyond that, I do want another example. DDT is a insecticide. It does a really good job. Insecticide, side meaning kill. What's it kill if it's an insecticide? Insects. It kills insects. So DDT, it was really, really popular because it worked really, really well. DDT, I'm not going to give us a big fancy name, but this was insecticide. Insecticide from, and we use it as human beings from about 1940 to 1970, in that range. Now, in the 1970s, they wound up banning its use, and it pretty much happened globally. Turns out that DDT, when it's sprayed on crops, it does a heck of a good job destroying all the insects. Like, fantastic job. Unfortunately, ecologists noticed something else started happening. We have what as our national bird? The eagle, specifically the bald eagle. Okay, any idea what Benjamin Franklin proposed it was? Interesting choice. Close, the turkey. He wanted the turkey to be that. Anyway, eagles, we can't kill them, right? We're not allowed to kill them. Has that always been the case?
No,
Uh-uh.
killed before in the 80s.
So, not as much as you might think.
Oh,
Eagles were endangered for a long time. And it turns out that in 1940 to 1970, we saw a huge drop in the number of eagles that exist on our country, in our country. Specifically, what was happening, and this is awesome, kind of, this thing worked really, 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 really well for killing bugs. Didn't kill humans when it touched them, didn't kill birds when it touched them, but there are some unintended, and thank goodness they recognized it. Turns out, what are some animals that eat bugs?
oh,
Birds eat bugs. Now, even if a bird isn't eating the bugs itself, do you think that there might be something bigger that does eat the bugs, and then the birds eat those bugs? Or eat the animals. So like mice eat bugs, and I think eagles eat mice. If there is DDT in the bugs that the mice eat, is there DDT in the mice? And if there's DDT in the mice, there's probably DDT in the eagles then that eat the mice. Everybody cool with that? What's happened with the concentration of DDT as it's gone up through each trophic level?
Oh, it's gotten bigger.
It's gotten bigger. Turns out this DDT insecticide was being biologically magnified through the food web, and it led to eggs, specifically eagle eggs, being extra fragile. Now, big whoop, you might think, but eggs are firm and they're hard. Whoa. Fragile? That's weird. Fragile. What happens if all of a sudden I lay 4 eggs and they're super fragile?
They easily break.
They easily break. And if they easily break, what doesn't come out of that egg?
The bird.
The bird. And if all of a sudden we don't have this reproductive process being completed, what happens with the overall eagle population? It plummets. This led to eagle eggs being extra fragile, which immediately led to critically endangered status. These things were on the brink of extinction. Critically endangered. Now, it was in this, oh my goodness, I'm really struggling to spell today. In this 30-year gap, we came pretty close to losing the bald eagle. Luckily, ecologists, biologists, just like we're training to be right now, recognized this. They started investigating it, and it led to the ban of this. There are more than just these that have impact through pollution, but these are 2 really great examples of the really bad idea of biological magnification. Cool. All right. Beyond that, not as much of a concern today. You guys ever been to Palawan?
Yeah.
You have been? In Samoa, are there coral reefs that are like pretty? Cool. Anybody ever been have you been to the Great Barrier Reef?
Oh, yeah.
You have? It's awesome, I assume. I've never been. I really hope to make it. Coral reefs are really bright and colorful, right? And they exist where? In the ocean, right? In coastal waters. Specifically tropical coastal waters, typically. Now, as we look at it, the ocean's gigantic. There is so much water in the ocean. Most of the water on our planet, right? Like 97.5% is in the ocean itself. Is there pollution in our air?
Yes.
Does sometimes water fall from the sky through the air? When water droplets fall, do you think that every once in a while they start to grab on to the stuff that's in the air? So if there's a bunch of CO2 in the air and a raindrop falls through it, I now get CO2 in my raindrop, yeah? Okay. It turns out that on our planet, through pollution, we have issues. We have a lot of different stuff in our air. Like, that's a bummer, but it happens. As we look at it, rain falls all over the planet, and it starts to pick up these pollutants in the rain itself. When you take something like CO2 and you mix it with water, you get CO2 water, right? Water with CO2 in it. That is known as carbonic acid. Now, acid does not necessarily have a negative connotation. Everything is either acidic, basic, or neither. That's everything. Soaps and stuff, when you use soap, it makes your hands feel wet. Slippery, that's a base. Basic. If you've ever touched bleach, you should wash it off if you do, but it's not going to kill you. If you've ever touched bleach, when you reach in and if you rub your fingers, they're super duper slippery. That's basic. What's an acid that you guys deal with all the time? You deal with pretty strong acids, I would argue, on a daily basis.
Oh, like cleaning sprays.
So usually basic. If it's cleaning, normally it's going to be a base. Soda is super acidic. Anything else that's maybe more healthy than soda? Orange, lemon, vinegar, pineapple, all of those things have citric acid in them. They're all acidic. Your gut has stomach acid in it, right? Cool. We don't want that on us. It's okay in our bellies. But, all right, as we're going through here, it turns out, though, that as this falls, whether it's rain or snow, if it's falling through a bunch of pollutants, you get what is known as acid precipitation. I don't remember the class nor the teacher exactly, but I do remember sitting in class when I was like 3rd or 4th grade, because in the 90s when I was young, acid rain was like a big concern. Acid rain is what they called it. Have you guys ever heard of acid rain? Yeah. Okay, not as talked about anymore. In the 90s, it was a huge concern. As we go through here, there's a bunch of different stuff. I'm going to give us a basic chemistry overview. This is not a vocab, But what we get is sulfur dioxide. Sulfur dioxide. Do you guys know what sulfur is on the periodic table? Sulfur is that yellow stuff in a match. Matches aren't yellow, but it's a stinky yellow thing that smells like eggs. They use it to make matches and lots of other stuff.
Did they get that like in a volcano?
You get it from volcanoes. Yep. If I've only ever had it happen once, when I was here my first or second year, I walked outside and it smelled like the sewers had broken. And there was a bunch of dust on my car, and I thought, that's weird. Turns out, the volcano had erupted pretty close to here, and there was ash on my car, and the stinky smell that I was smelling that I thought was the sewers was just all the sulfuric gas that was leaking out of the volcano. There's a volcano about 10 miles that way. Big one. Big one. It's active.
Underwater?
Nope, it's over there. If it's hard to see, you have to be on a really, really clear day.
You could see it.
You can see it from here. Has to be really clear because you have to look over the mountains across the ocean, like past Safeway.
Yeah.
But you can see it. That's where they're building the geothermal plant to harness that energy.
Oh, well, they're gonna build down and.
Yep, they dig down and then use that heat. But yeah, there's an active caldera on top. Yeah, cool. All right, anyway, turns out that one good cause of this, and there's several of them, SO2, which is sulfur, is S, and O2 just means there's two oxygens, and that's dioxide. Sulfur dioxide is in the air. It happens. Pretty common from combustion and, lost my train of thought. Volcanoes. Cool. So this is in the air. And when rain falls, this mixes, or combines if you'd rather, with rain to form a couple different things. And again, we're not in a chemistry class, but it's nice to get a little bit of exposure to it. This forms H2SO4, which is sulfuric acid. You will find this is battery acid, just so you know, the same stuff that they use in batteries. It forms H2SO4, and it happens to form nitric acid. And nitric acid, which is an acid that has nitrogen as one of its primary components. Okay. All of this stuff falls, excuse me, to the ground or to the ocean, right? Turns out that when you have either the sulfuric acid or this nitric acid and it lands on the ground, it pulls, I'm just going to put underneath, pulls some stuff out of the soil. Specifically, it pulls the following. I'm going to write these in their chemical names first. Their symbols. Do you know what Ca is? Calcium, good. It pulls calcium. Is calcium an important nutrient for you?
Yeah.
You think it's important for plants too?
Yes.
Super duper. It pulls calcium out of the soil. It also pulls K out of the soil.
I know this one. Kelp. No.
Think bananas. Ooh, somebody said it, I think. Potassium. It pulls calcium and it pulls potassium out of the soil, which I'm running out of space at this little spot. You think those are two things that plants need?
Yes.
And if it pulls it out of the soil, what happens to the plants that are there?
Start dying.
Plants start to struggle. Whether or not they die depends on how hardcore it is. But from acid precip, which is just pollution in the air and then the rain falling down, this happens. Okay, beyond that, this can be severe enough to kill plants. It can be severe enough to kill animals that eat those plants. Like, there's a huge impact when this happens. Other one that we don't need to write down, but back to the CO2 in the air. Carbonic acid. Our ocean, do you think, 7 is neutral. Have you guys talked about pH stuff ever?
I think so.
Okay, so a pH of 7 is neutral. Means it's not acidic and it's not basic. Okay, it goes all the way up to 14, which is like bleach, and a little bit higher than bleach is almost 14. 14 is as high as it goes, and 0.01 is as low as it goes.
Wait, what's those paper that they, when they put in water, they can...
pH strips.
Oh,
Yep,
yeah.
you're measuring just that. When you look to see what color it changes,
Yeah.
you're measuring the pH. We can drink pretty acidic stuff. We're not good with basic stuff. Basic stuff dries out our skin. Like, I can drink a pH of 3 or 2 Coca-Cola, and it doesn't hurt me. I cannot drink a pH 11 dish soap because that's toxic to me. We do well with acids, not well with bases. Now, with that in mind, our ocean is salt water. 7 is neutral, Bigger than 7 means it's basic. Smaller than 7 means it's acidic. Any idea where our pH is in our ocean? Like shot in the dark. Do you think it's a little bit more acidic or a little bit more basic? Okay, one of you was right. Nice job there, RJ. The ocean is basic. It's about 8.3. That's what it naturally wants to be. Now, over the past 150, 200 years, we've seen the pH change wildly. That's not really super wildly. It's not going to seem wildly, but I promise it is. It's gone from about 8.3 to around 8.1. Seems minor, right? It's not. Just that little change means that our ocean is getting either less basic or more acidic. They're the same thing. We're getting more towards 7 or below 7. When that happens, huge impact on stuff. If you wanted to visit the Great Barrier Reef, where would you have to go?
Australia.
You would have to go to Australia. Now, this one, if you want to see the Great Barrier Reef, I would encourage, start thinking of a way to save, and we'll talk about why. Coral Reef.
Oh, it's because the thing's gonna get bleached out now.
So you just used the term bleach, and I love it. Bleach is basic, which our oceans want to be. This is a portion of the Great Barrier Reef. Bam, bam. Is that what you saw when you saw the Great Barrier? Is this what you guys see when you look at reefs in Palawan or in Hawaii or wherever you see a reef? Andrew, have you ever seen a reef in person?
Yeah,
Have you seen a picture of a reef?
Oh yeah. Yeah.
Okay, so let's find, so I'm not going to find it. Hey, there it is. That's what reefs are supposed to look like.
Yeah, look at it.
Okay, now it's out of focus and stuff. The one on the right, I assume it's the same reef. What's happened?
They turn into like bones.
So they look like bones almost, right? Like they're just white now. They've been bleached. The color is gone. Do you see all the fish swimming around on the right picture? Do you see all the plant life in the right picture? This ecosystem has gotten kind of destroyed, I would argue, right? Like, not even argue. I'll just tell you. I can see it. This thing has been destroyed. That little change from 8.3 to 8.1 is leading to coral reef bleaching. There is the possibility that without any changes made by my generation or your generation, that this is what is waiting for the Great Barrier Reef. Because of the pollutants that are in the air that fall through acid precip, it's changing our oceans to such an extent that this is going to become a larger and larger problem. Yes, sir.
Well, aren't we telling that wrong right now?
Not that I know of. Like I guarantee there are conservation efforts being made, but unless the entire world agrees to do it, like if Australia quits polluting, awesome, it'll help it. But if China and the U.S. and all of us don't stop, then eventually, like it's inevitable. With that in mind, like that's everything just sounds so doom and gloom when we talk about climate change. But check it. I just want to remind you, this is bad. That is my opinion. Okay. But if that land is now available for other things to grow that maybe can handle that different pH value, do you think other stuff will replace this? Probably, right? It might not be the same reef. Maybe it'll be a different sort of reef. Who knows what it'll eventually be. This sucks for the coral reef and for people who want to see the coral reef, but it might be really awesome and advantageous for things that want to replace the coral reef. Okay, always keep that in mind as you're going through it and thinking about it. Okay, beyond that. You guys hear something?
I think it's lazy milk.
I have broken 2 or 3 microphones in my day doing exactly that. Cool. All right. Last couple little pieces. Do you guys remember when we talked about rivers and how their characteristics change as they go down the mountain? Up top, it's really cold, really full of oxygen. It's going too fast. Sediment doesn't build up. Plants don't grow, blah, 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 right? Okay. As it goes down and water slows, all of a sudden you get sediment building up and you get a fantastic environment for stuff to grow, yeah? Look back in your notes or in your brain if you want to do that first. See if you can recall what we said, how we described those lakes and rivers that didn't have any life compared with the ones that did. There's a particular phrase we used. Holy cow, that was so much faster than I was expecting. We had an oligotrophic, which was what?
Lakes are common in high altitudes.
So oligo meaning what? Did you write it down when we had it?
Nutrient
Nutrient poor. Oligotrophic was bad. No nutrients. What was the other one that we said?
nutrient rich, eutrophic.
eutrophic was good, right? So, just as a reminder, eutrophic is good, oligotrophic is bad. Okay, trophic referring to the nutrients. So, continuing on, we're in our pollution idea still. We should talk about eutrophication. Goodness gracious. Okay, weird idea that winds up happening here, and I'm going to write that so much nicer. Eutrophication. Eutrophic, T-R-O, and it's not a vocab, but it's coming out in caps. You're good. It's not a vocab. I don't know why I started this. Eutrophication. Okay. Eutrophic meant that it was good. There was a lot of nutrients there. Now, things do really well when there's lots of nutrients, right? Typically, life needs nutrients, and it grows really well. Now, is this a good thing? If we said, hey, eutrophication is happening, with that in mind, is this good or bad?
I think it's good.
It sounds good, right? Because we're making stuff eutrophic, lots of nutrients. It can be good. Here, however, though, since we're in our doom and gloom phase right now, eutrophication is usually a great thing. It can be bad, though. Now, this isn't a true definition, but this is just more of an example. What gets into waterways in our, like, if pollutants get into the water, do people grow plants and farms and stuff? Let me rephrase this. Do farms exist? Do we use fertilizers? That fertilizer stays only exactly where we put it forever. Is that true? If I put a bunch of fertilizer on my crop, is it there or does it run off? Some of it runs off, right? And I'm trying to think of the word that we use, percolates down into the groundwaters. That's an issue. Okay, so check it out. When we get fertilizers or animal waste or whatever we're dealing with, some pollutants typically from agriculture, fertilizers and animal waste, which we'll just put in parentheses. These guys are rich, really rich in nitrogen. Do you guys know the symbol for nitrogen? Good guess. It's N. Okay, when we get these things that are really rich in nitrogen and phosphorus, sometimes they flow to rivers. Sometimes, and I'm going to say run off instead of flow. Run off into rivers. Okay. Assuming that these fertilizers are used to grow crops, when these things get into rivers, they help what grow really well?
The plants.
Plants. Could be mold. We're going to kind of split the difference between them. If we have a whole lot of this extra nitrogen and phosphorus that helps plant and plant-like things grow really well, do you agree that this could possibly lead to algae being really successful? So check this out. We lead to what are known as algal blooms. When you think of blooming, think of a flower. Like, here's a flower, right, and it blooms and it does this, and now it's big. We get a huge increase in algae. Now, unless we keep feeding all of these fertilizers and nutrients into the water, that population blows up, but then when we stop doing it or it stops getting supplied, what do you think happens with that big algae population? It starts dying, right? So we're kind of stuck in this situation where all of a sudden we've been doing it and the algae's been like doing really well, unfortunately due to runoff from fertilizers, but we don't constantly fertilize. Like big rains will wash swaths of fertilizer and stuff in. But check it out. The algal blooms are huge. Then the nutrients stop. So we've been eutrophied. We've added a ton of nutrients. Nutrients stop coming. And this is just a natural process during the winter when we don't water crops, there's no runoff. Okay? Now, in this process, you said it a second ago, but repeat it, Bam Bam. What happens with all that algae that was really thriving and then it stops? Algae death. Algae population dies. Okay. Whether you're a plant, an animal, doesn't matter. We now had a huge population of algae that just died. It's dead. What happens to stuff when it dies? It starts to decompose. Decomposing requires chemical reactions. it decomposes. I'm going to put that here, and decomposes. When it decomposes, what you're really seeing is a bunch of bacteria and stuff eat it. That's what's happening. There's a chemical reaction going on. It's turning that. Detritivores, if I recall, are the bacteria and stuff that do this. Okay, algae population dies and it starts to decompose, which means there's now a bunch of bacteria that's decomposing it. What do you think bacteria need to decompose? Any specific elements or really important things that might be in water that other life might also need? Could be soil. What do we need? Oxygen. Fish need oxygen. What do you think bacteria might need when they're doing this decomposition? So the algae are dead and it starts to decompose. All of the oxygen, or a lot, most if we will, most of the O2 in water, in the water, is used by who? One more time.
Human or?
So
Oh, a plant.
normally we want to say it's plants and fish and stuff, right? But in this situation, big algae population, and then the nutrients stop, so they start dying. And then what happens with that huge population of algae that was there? They start to
I mean,
decompose, and to decompose, they have to get eaten by these bacteria, right? And what did we just say the bacteria probably also use?
oxygen.
So the bacteria from this big algal bloom take all the oxygen. All right. Has it started to feel like maybe it's not a positive anymore right now? We'll get there. If it doesn't feel positive yet, eutrophication we think of as a good thing because we're adding nutrients. But if we don't add them carefully, or we add too much or whatever, this happens. All of a sudden, we had water that had a lot of oxygen in it for plants and animals to use. The bacteria come in and they use all of it. What happens with all the plants and the animals that need oxygen still? Holy death. Okay, looking at this, we're going to sneak that. I'm not going to write holy death yet. Maybe I will. But we get low oxygen levels. And I'm going to say O2. Now, this is known as hypoxic. Hypo meaning little, oxic as in oxygen. We get low O2 levels, which hurt again who? Might hurt plants. Plants make oxygen typically. Animals use this oxygen though. What is the phrase I said I wasn't going to write yet? Holy death. Of animals. Okay. There are rivers where animals don't exist, and we talked about those as being the oligotrophic. Turns out that oftentimes what happens is what leads to that terrible condition where there's no resources or not enough nutrients or elements needed is it's a result of a big eutrophication that happened first. If we pump artificially inflate a population, huge issue. Okay. Last little piece. I'm trying to think of a good example. It's so unique being here because we don't have a ton. We don't have a lot of wild animals on this island. We do in the water, but we don't on the island. If, hypothetically, we were to bring in, I don't know, pick an animal that you think would thrive here.
Polar bear.
Polar bears would do really poorly here.
Oh,
Oh, a bear?
A brown bear would do okay.
moose,
A wolf, what would a wolf eat to sustain itself?
rabbit. Wait, yeah, rabbit.
Do we have rabbits?
No, they eat the squirrel.
Hog Island.
Squirrels.
On Hog Island there are. Do you think there's enough squirrels around for wolves to sustain their population? No. Probably not.
Wait, the snow foxes.
So we already have foxes, right?
Yeah.
Now, hypothetically, if we were to introduce what's something a little bit bigger than a fox but smaller, bears would be okay because of salmon.
Use.
They would be all right because of the salmon.
Use.
Say it again.
Deers.
Deer? Deer would probably be okay here. They actually tried years ago to have caribou on this island, like a long time ago. I don't know why it didn't stick. It seems like the perfect place for caribou.
How about the mooses?
Moose would struggle. We don't have the right plants here. Anyway, let's introduce something that's going to eat or compete with foxes. What would compete with a fox?
A dog. Huh.
Wild dogs. Sure, I'm okay with that. Let's say that we had wild dogs show up. And they're a little bit bigger than foxes typically. Foxes are small. Wild dogs probably wouldn't eat the foxes.
Yes, sir.
But what would they eat?
Random foxes.
They would
Squirrels?
start eating squirrels more and more, right? And maybe even eat some life there. Do we naturally find dogs here? No. So if we introduced wild dogs on this island, would it have like huge effect on the animal populations here? Or if we introduced a new plant, so like we got a lot of salmonberry bushes. In California, blackberries where you live or no? Too far south in Bakersfield.
Yeah.
Okay. Northern California, Washington, there's tons of blackberries. You think blackberries would grow here?
Yeah.
I bet they would. I think they'd grow really, really well here. We don't have blackberries though. If I planted a blackberry bush out front right now and it was big and prosperous, let's say, in 20 years, what do you think you're going to find all across the island? Blackberries. Not natural, but it happens, right?
Yeah.
Okay. They're not naturally found here. What do we call the name, and you might have heard it before, when we introduce or somehow introduce a new species that outcompetes and impacts others? So it could be a predator if we're talking about like animals, for sure. Have you guys ever heard the word invasive? Have you ever heard of an invasive species?
Yeah.
Okay. Invasive species are the last little piece that we're going to look at. If you guys haven't noticed, it doesn't look like we're going to get to do the quiz today. Sorry. Cool. We're going to define for ourselves invasive species. And this is the last one that we're going to deal with. We're going to say that by definition, invasive species, what these guys do is they significantly, so in a like really impactful way, they significantly modify or disrupt a habitat when introduced. Now, I'm going to be even more, it feels odd to do, but I don't want to just stop it there. They significantly modify or disrupt a habitat when introduced to non-native habitat. Okay, sorry it's kind of wordy. I'm not going to write these parts down, but I'm going to talk about it. What's your least favorite bug other than mosquito?
Flies.
You don't like flies?
I hate flies.
Okay.
Cockroach.
Cockroaches. We don't get a ton of cockroaches here, which is nice. I also hate cockroaches. They gross me out. Cockroaches.
Come on, they're friendly. If it's funny,
I don't know that I'd say friendly necessarily, but they're not really bad, right? They don't really do anything to you. Check it out. Who in here has been bitten by an ant? Black ant or red ant?
Red.
Where? Both? You've been bitten by a black ant?
Yeah, bears.
Pretty rare. Interesting. Okay. Where?
Oh, yeah.
Probably not in Alaska. In the Philippines? Are there fire ants down south?
Yes.
Like in the U.S.?
Oh, US.
How long have they been around in the U.S.?
Billions of years.
You think so? Like, ants have been around for a long time. You think we've had fire ants in the U.S. for ever, essentially? No. Turns out fire ants did not exist here till like the 1800s. They came on a boat from Europe. Somebody brought ants to the U.S. Similarly, when you think of, man, there's all sorts of weird things. This one's not invasive. Fire ants are invasive. They showed up in the U.S., and in the 1920s is when they were to the point where we couldn't fight them off anymore. The fire ants won the battle. They're not from here. They thrive here. What do fire ants eat?
Other ants.
They could eat ants. Sometimes ants are crazy if you've never really looked at them. They're wild. Will they eat animals?
Yeah.
They will. So not in the U.S. as much, but there are places in the world where ants will eat children, like infants, babies. Ants can eat babies if there's enough ants, which is terrifying. Is it possible they could go into a fox's den and eat baby fox then?
Yes.
And they could cause havoc just within that ecosystem, right? They're invasive. Other places, plants are really common invasive species. Plants just move all around the world because of people and birds and all that. Since 1750, about 40% of the extinctions that we've seen in North America are a direct result of invasive species. So as scary and bad as pollution and stuff seems, overexploitation, those are all bad things. Invasive species are just as bad. I cannot take firewood from South Dakota to California. I'm not allowed to do that. It cannot cross state lines because the forests in South Dakota are so impacted by particular type of beetles that have not made it to California yet that we get terrible forest fires. So does California, obviously. But we don't want to kill their forest with this disease. Invasive species wreak havoc. Over the weekend, you do get a little homework. No quiz today. You, this weekend, will do homework 5.2, which you'll find on page 112. And you get the privilege of working problems 1 through 5. This will be due on Monday, which is 16, 17, 11, 18. One more full week, and then Thanksgiving.
Yes. I go home this weekend.
I mean, in 6 hours, sure.
Oh,
All right. Appreciate you guys as always.